Alright, welcome to another draft physics presentation. So Holiday has, made a video, sort of going back to saying, oh yeah, maybe they're right, maybe their math is right on this Doppler effect, which I think is a mistake on his part, but whatever, he may do as he pleases. So let's understand, the primary point I've made is, first, this is a sound experiment. There should be evidence of this phenomenon. If there's this big a difference between transmitters and receivers, we should have a physical experiment that demonstrates it somewhere. Where is it? Not saying it doesn't exist. I'm just saying no one's just doing the obvious thing, which is, here's the physical evidence of it happening. It seems like a very doable experiment, so it seems like it should have been done. Second, as I brought up in my first initial comment to Professor Lewin, well, what about the case of two people moving the same speed having a conversation on a train? Is the argument that somehow the voices are going to be altered depending on which way the train's going? I mean, if the train's going one way, my voice gets altered. If the train's going the other way, the other guy's voice gets altered. Why are you giving me examples of things going different speeds? Why don't you have them go the same speed? Or why don't you just have one person talking and then the other person talking back? Those two circumstances should somehow be dramatically different somehow. One person's voice should be more affected than the other person's, if this theory was correct. And again, the exclusion that Professor Lewin made was that this only affects sound waves, not EM. So this has nothing to do with any light experiments or anything like that. They apparently don't follow this rule. Yet every example I've seen is examples you'd use in these other medias also. So I don't really understand that either. So I guess I could read some of the comments, but they're really not very useful. But I guess we should read some of them. Okay, well, this one was okay, right? Hello, Gary. In the professor's video, the answers are 400 and 250. Which one is wrong? Can you do the calculation in the video? I don't know if I do the calculation because I'm not sure the formula makes any sense. I would argue that this thing is on a standard wave, standard scale. That from 0 to 100, in the sense of you double the frequency or you have the frequency depending on which way you go. But every time you get to the speed of sound, in the sense the combined speed equals the speed of sound, you'll either cut the frequency in half or you'll double the frequency. So I would say the answer is probably 500, since it was the speed of sound and they were moving away from each other. So the correct answer would have been 500. Neither 400 or 250. But I'm only thinking it's right that the Doppler shift doubles the frequency if the combined speeds add up to the speed of sound. Alright, so I don't know what this delta dumbfuck thing was. I won't bother reading it because it's not on any subject. But he has the weird thing in here, like, hidden up my sleeve while being done none the wiser. And yes, while it's true that you will eventually recover from this recent turn of events, it remains unclear whether or not your social status on this website will remain at its current level. I don't know, perhaps even about. So this guy says, look, it's bloody simple. I think it's simple, but obviously we don't think it's simple the same way. Just think of a receiver moving half the speed of sound. When a peak reaches it, then it will have moved one half of a wavelength by the time another peak reaches it. Yeah, well, you understand that the movement is the very thing that's undoing the compression of the wave that could have been caused by something else, or it's magnifying an effect. But that's all it's doing. It's either just expanding or compressing the period of the event. And its own movement is exactly what's doing that. So I guess I just don't understand your point of adding up these movements, because obviously these movements added up are exactly what is compressing or decompressing the wave. So I don't understand how you think that's a persuasive argument. So we got another animation, which is sort of annoying. Why can't we have a real physical experiment? So this is attempting to illustrate the difference. So we have stationary and moving. So in one case the receiver's moving, in the other case the transmitter's moving, and we have these different numbers, 5 to 7, which would be, I guess, the same ratio as 250 to 4, but whatever. But again, it's an animation. I don't know, why can't we find real evidence instead of animated evidence? Animations that just rely on mathematics that I don't really understand as being correct. So it just doesn't seem like we're getting anywhere here. Let's see. Let's see. Made an illustration for that typed abomination. So he's got some other illustration. My modified scenario, and I hope you consider it carefully. Isn't that the animation I just played? I think it's the one I just played, right? No, there's another one there. Let's see if it's the same. It's the same damn link. People. So they keep doing the scenario 1 thing and scenario 2, and I don't think there's any point in reading them because I can't follow any of it as making that much sense or any useful sense. I think Professor Lewin misspoke. Okay, so at least that was alright. We already did that comment, so that's all there really was here. It's the same old arguments. Okay, so I'll just draw what I think happens, and fuck this. Yeah. I mean, it's this. I just don't see how look in the speed of light example. If there's a constant speed, there's always issues with things that have a constant speed. But I don't see how sound makes it any difference, because the travel speed of a medium doesn't have any other. It's no different than the travel speed of photons. If photons were in a medium, are you arguing that this effect would exist then? Or are you arguing that it doesn't exist with photons? Again, it's just so very unclear, this statement that this only affects sound. Well, what is so different about sound than about light? I mean, there's no way for you personally to look at light and say, oh, I can see that it's not, that's not perturbations in an ether. How do you see that? So let's say you just got a vibrating source, and the vibrations, I would argue, are speed of sound vibrations, and that's what creates a wave in the medium. And so as Hofladay sort of stated, he was thinking originally that these are just independent things. Once they're created, they're just independent waves, little noise, little vibrations, and they just the speed that the vibration moves through the atmosphere is this set speed of whatever, 340 meters per second, and that's all it is. So if I take this box and I move it, close to the speed of sound away, then you would expect that these bars, this noise, right, would then be double the frequency, in terms of double the wavelength. So at half the frequency, they would get spread apart. And if it was going the other way, that they would get compressed, and that would double the frequency. And that's it. So now we're done with transmitting. Simple enough. A kind of a straight ratio. Okay, here's going the speed of sound, a percentage of the speed of sound. So let's call that 100% of the speed of sound that you're traveling. And you could argue that this other line could be the way I drew it, I don't know if I can make it into a proper chart. And it's probably didn't need this line, because I want to do something like this line. And so you would double the frequency. So this would be the frequency as you go 100% of the speed of light, and it would just be a line, a straight line. There wouldn't be anything complicated about the chart. Wouldn't have any lumps or weirdness to it. It'd just be a straight line. Half the distance, half the height. Alright, so anyway, so on the receiver end, there's nothing else happening. You have a thing in space. There's no, as much as wind is something, it's not playing a role. So it's just a thing, and there these little waves are floating through space and coming at it. And I probably should draw them going well, it doesn't really matter which direction I have them. And they move a constant speed, like light. They just move a constant speed. They mind their own business. And if this thing is moving into them, it's going to hit more of them quicker. And if it's moving away from them, it's going to receive them slower. And I just don't see how it's any different than the transmitter. It's just going to do the same thing. I mean, you can do this nonsense of saying, well, it's going a certain speed in space, but it's the same space it's traveling in. It's traveling in the same space as the waves are. Yeah, you could say this is going 340 meters per second away. Well, then this sound, okay, can't get to it, right? Because it's only going 300 meters per second from the source. So it can't gain anything on it. But as soon as it can, as soon as this is something less than 340, it starts to absorb the waves one at a time. And you know, the closer that speed gets to the speed of sound, I mean, the further away it gets, the less effect it has on making these waves even longer. So if it's going 0, there's no effect. If it's going 100% the speed of sound, then it's going to have a doubling effect. And in this case, the wavelength is being doubled, not the frequency. So it'll be spread out further. I don't see how it's any different for light or anything else. It's going to get absorbed at the rate at which the waves are moving, but they still have a distance between them, and the only thing being affected by the absorption is the distance between them. It's not affecting the wave speed at all. This can't affect the speed of the waves at all. All it can do is absorb them at a new speed, just as this one produced them at a new speed. So I don't see any room for all of this mumbo jumbo. Alright, it's probably too much of a simplification to be acceptable. So I just say, do the scenario. Show me going the same speed. Show me two things moving into each other, the transmitter and the receiver. And show me how the receiver hears this transmitter differently. Just two people talking on the train, an open car train. Explain to me how one person is going to be affected by, not twice as much, but is going to have a 60% increase in the amount of change in their pitch of their voice. And explain why. Physically, because I don't think these are physical explanations. Alright, so the thing I wanted to get to too was Hofladay's video, because it was he had this part later in it, where he's doing the relativity crap, and he referenced some of my statements, and I just think he did a very poor job of it. So I wanted to fix what little damage he attempted.
In Mendham's some of Mendham's assumptions about Venus.
Okay, now let's just understand. When I've used examples of this idea that light comes from things, and when we see them, we're seeing them from the past. The light doesn't move with the object, so we don't see. And I've used stars as an example. I've used galaxies as an example. I use all kinds of things that give off light because I think it's true for all of them. And he thinks that suns are different. So things that reflect light, we actually are seeing them where they are. But things that don't reflect light, we're not seeing them where they are. So, yeah, let's play with that because I think it's ludicrous.
Jupiter.
Gotta speed this up. 30 videos.
When we see Jupiter,
I have it all the way up. I think that's all the way. Can I go to 5? No. Okay, I'll have to settle for 1.5.
Otherwise, I'll keep saying Venus, because he does use that as an example.
I've used lots of examples, that's right.
But it's essentially functioning as a reflector to Earth.
Alright, so now his argument is that somehow reflected light isn't the same as emitted light. Now, I think a lot of physicists, Feynman even, would say that a reflection is an emission, because what's really happening is essentially the reflecting object is catching the photon and throwing it back. So it's going to, whatever imposition of its state, is going to get influence on the photon. Photons don't purely reflect. They don't just purely reflect in some kind of way where they're uninfluenced by the thing they're reflecting off of. They are partially, at least, absorbed and then re-emitted. So in my physics, for example, they would have to travel through a proton, let's say, and the proton, it creates the angle in, angle out, the 90-degree thing, sort of, in the sense that it will create the angular reflection. And so it has to be, essentially, it has to go through the proton, and the proton's motion then would be affecting the emission of the new photon in terms of its momentum just as much as if it was a pure emission, just as much as if the photon was created on Jupiter and shot out of Jupiter. But he thinks there's actually a difference. So first, I don't think he has any evidence that reflections aren't absorptions and re-emissions, because I think a lot of physics believes that. A lot of his physics believes that. If you polled all the physicists, I think the majority of them would say that a reflection is an absorption. It's just an absorption with a spit it back really quick.
And where the laws of reflection are applying, the angle of incident is equal to the angle of reflection. Phi. Right. There's no momentum concerns here. No momentum concerns of the body of Jupiter.
So again, I would argue that I think there are momentum concerns, and I think momentum can be changed by reflections. So they're a substantial interaction, and they're not inconsequential. So again, and this argument of momentum gets very complicated when you start talking about objects that have spin, because obviously the object's momentum in terms of its directional vector is sort of lost forever. Once it contributes to a spin.
But suppose there's a man with a torch on Jupiter, traveling with the momentum, and he shines the torch at Earth. Those photons from the torch
not drawing this very well.
Part of the momentum of Jupiter.
What does that even mean? Part of the momentum.
So the
part of the momentum. It's kind of a silly line. Part of the momentum. So Jupiter's also rotating. So he's basically arguing, if I shot a laser off the surface of Jupiter, okay, that the laser light, okay, will essentially, whatever movement I have, the light in space will move with the laser somehow. It'll move in the same direction that the laser beam. So the light goes, the photons don't leave straight line, they leave in this kind of direction. In the sense they'll go to a future location that is going to create the impression of where the laser would be. So if there was a 10-minute time delay between this position and this position, we would see actually the flashlight. Now we wouldn't see Jupiter because it's reflected light. But if the guy had a laser beam and he's shooting it, the laser beam we would see at the right location, that is where Jupiter is right now, because it would have moved, and the reflected light would still be way back here in the past. So we'd have this perception of Jupiter. We'd see the reflected light back there, and we would see the laser beam over there, not on Jupiter anymore. So where Jupiter is, the man would look like he was 10 minutes away. in terms of arc-second distance and stuff. Now that obviously doesn't make any sense, right? I mean, that's not a sensible argument to make. That we wouldn't see the man shooting the laser on Jupiter. And I think, like I said, doesn't everybody think, I mean, who doesn't think that when we see a star in space, that we're seeing where it was? Not where it currently is, but where it was. Or not where it was going. Not whatever its vector was. So any momentum it had in a direction. And we're not seeing it where it would have landed. See, the irony of this thing is you could have a star. I should draw it, but I won't. You could have a star, and it could be moving. Now, Hawthorne would say the light will come off at an angle so that we'll see it where it should be, where it will be in the future. So in the future, when we see the light, we'll see it in the right location because the light bent properly. But what if, when the sun was going from this, point A to point B, what if that sun crashes into something and blows up and never to be seen again? Then he's going to argue that somehow we'd still see it in this future location where it never even got. The light here would have had the information of where it's going. It would have made the illusion of where it's supposed to be in its current modern position with the old light. So this is the old light produced back here is going to make us think it's way up here, and it doesn't even exist at all because it blew up here. I mean, the paradoxes are insane. This cannot possibly be the truth. And he talks like this is proven, like we have all this evidence that demonstrates that, and this is what conventional physics believes, which I don't even think is true. I mean, he's arguing like, oh yeah, this is the real physics, this is what they think. And I don't think he has any evidence that this is what they think. So he's giving me a lecture that I'm not properly paraphrasing how modern physics thinks the truth works. I don't think they think this. I don't think they're this stupid.
Is by the time we reach this situation, by the time we reach, we see Jupiter by this reflection mechanism, it is true that what we're seeing is an apparent image rather than the true image, i.e.
So it's just wrong to say the true image. We're seeing the real image. It just obviously takes the image a long time to get here. But when it gets here, it's the real place. It's where it was, on the straight line. I mean, this idea that somehow the light bent and therefore gives us the impression of some new location where Jupiter should be if it didn't blow up, or if something didn't hit it and change its speed. I don't think there's any viability for this theory at all, especially when he makes this distinction between light produced by a laser beam and reflected light. And again, this silly notion that somehow a man standing on Jupiter, we would see Jupiter and we would see the laser guy over here all by himself.
Jupiter's moved on, right? But when we see light from a torch, this and I think DraftScience forgets this, is that I'm trying to explain. I'm not actually ever saying this is reality, right? I'm saying this is the theories that we work by, that orthodox science works.
Again, so he says this is their theory. I don't think it's their theory. I don't think they have a theory. I don't think they bother explaining their paradoxes. So, to say that this theory that Feynman believed there was a difference between reflected light and laser light off or flashlight light, I don't think you have any evidence of that.
By and the conclusions and inferences therein of orthodox science about reality and the models that we use.
Well, again, you say the models that we use, and then you I mean, there's just duplicity in this. Either argue what you think is rational and has a chance of being the truth, or don't argue. But I don't understand this. We believe it, but I'm not really committed to it at all. We use it, but I'm not committed to it at all. you do all this we talk, and then you distance yourself from it and say, I'm not really advocating that this is the truth, I'm just explaining to you what they say. And you keep saying we. You're saying they, to say, I didn't vote for it, and then you vote for it. It's just crap.
As I understand it, when a man with a torch or laser beam or whatever shines a beam, those photons are also carrying part of the momentum of Jupiter away with it. And
again, when you say part of the momentum, you're really saying all of the momentum. Whatever its velocity is, that beam of light will maintain that velocity. So the emitter's moving on the planet this way in space, the same way as the planet's moving at any 1 second, right? So obviously at each second it could be moving a different vector, but at 1 second in time it's going to be moving some vector. And you're saying that the emitting source has that movement, and that the beam itself will also have that movement. I don't think there's any chance that's frickin' accurate.
So we're seeing a true image of where the torch is, because in a sense, as it travels,
but obviously it's not as it travels. Like I said, to make it make any sense, you have to do this stupid hypotenuse thing. You have to give it a vector. So somehow the momentum this way has to be converted into a vector this way. But whatever. It's still nonsense.
We are, in essence, the very light clock under scrutiny, or part of the system, right?
Again, I don't know what that has to do with whether or not you think suns, when we see a sun in the sky, a star, do we think that star is at that place right now, or do we understand that no, that's where it was millions of years ago?
Now, when I say it carries part of the momentum, it still has only the speed of light. But whereas this observer might understand and do a private measurement of the frequency of that light, our measured frequency will be different from his. And that's just one of the ways light and special relativity will account for this apparent paradox of travelling the further hypotenuse distance at the same speed of light and everything working out.
Right, so traveling more distance at the speed of light. Like so you like somehow you can have a constant and do that, when you really can't. So you're just creating artificial distance, or you're creating artificial speed, but one or the other. It's magical dark distance or something. So now we just invent dark distance in the universe. It's not real distance, it's just dark distance.
Okay. Other ways is that there's a relative shrinkage in the so-called future direction, as Mendham puts it. Yeah.
Yeah, so dark space. We create magical space that we don't have to account for. We can travel. It appears to be there, but it doesn't really exist. It's fake. And we don't have to pay any attention to the truth. Sorry, yes, this video is just so slow that I think we're just going to have to jump through this.
There is no Pythagorean paradox.
Alright, so he says there's no Pythagorean paradox, which is somehow the hypotenuse line isn't really longer, and it doesn't really take light longer to travel the longer line because they have magical compressed universe bullshit and blah 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 blah. And I'm saying yes, I think there's a real paradox, and I think it's a real I think it's just theoretical mush, and it doesn't have any evidence defending it.
That's the claim of special relativity. That's the claim of orthodox science. That is what's taught.
Yeah, and I pointed out how it doesn't have physical evidence defending it beyond the things I've already explained, like muons or something. Yes, the atomic decay is retarded. So you have evidence of time dilation, but that has nothing to do with space being dilated or any kind of compressions or any other kind of nonsense. It just has to do with the fact that motion affects the metabolism of atomic structure.
That all these fungible measurements precisely undo the expected violation.
I don't think they precisely undo. So again, you say again, is this argument that they have this perfect math? I don't think that you have perfect math for the whole light mirror problem. I don't think you can actually make the light hit the mirror at the right place at the right time without just a complete fudge of faking it and say, I can make light go faster than the speed of light without breaking the laws, physical laws. And again, pretending, well, when I want it to compress, it'll compress, and when the compression is annoying, then it won't compress. I mean, it sounds just like the double slit experiment in the sense, well, yeah, single slits, Huygens makes 2 waves. Double slit, Huygens makes just 2 waves. Why shouldn't it make 4, since they're 2 slits? I mean, simple questions.
So, to call special relativity wrong is one thing, but to claim that it infers the paradox is wrong.
Well, you keep saying I can't say it's 2 momentums, when the only way he's getting around the 2 momentum problem, the baseball problem. Baseballs can change their speed, so they can go faster. And so you can have a relative game of catch where baseball seems like it's going 50 miles an hour, but in reality you're on a train and the baseball is really going 82 miles an hour. And baseballs can do that, but a photon can't. And he's not dealing with that fact in any real way except to say, well, it's our made-up universe that as soon as you start traveling the hypotenuse, I shrink the entire universe, and therefore the hypotenuse is the same size as the sides were because I shrank the universe for you. I mean, they're bullshit answers.
You have to understand it and be able to do the Lorentz calculations to understand how it fixes the paradox.
Well, whatever. The Lorentz transformations are just making a crooked line out of a straight line, but whatever. How they correct or fix anything is all your delusion, in my opinion. You haven't proven any of that crap to be of any use at all.
It has occurred to me, you know, that for all the particle accelerators, you know, and the surprises in physics, there's been huge upsets in physics, and it wouldn't surprise me that if Emendum was on to something about the future upsets, you know, whether, you know, we don't, to my knowledge, do experiments with atoms or structures, accelerate them to the speed of light and see whether they maintain their structure. Yeah? What we do is we take nucleuses, we've clashed those, and we take the component.
Well, I think they've surely tried, and that's my whole point. You have to put so much energy in that you annihilate the thing. So, yeah, they can't move matter because it's too stressful. And as I pointed out, and elementally, it won't do it. You can't do it because the elements can't move more than one way at the same time, and the elements have already got their own motion. They can't go faster than the speed of light, and they already have their internal motion, so you can't add a bunch of extra motion. But anyway, I don't want to. We've already been over this shit, so hell with it. But yeah, Well, anyway, I'm not totally satisfied that I provided a hard enough description of my objections here to this Doppler nonsense, but I would first want to see, why is there no physical evidence of this sound problem? Why is it only happen with sound? What is the physical reason why sound is different than light? How is it physically different? They're both things that can only move a constant speed. So how can the physics be actually different? Those are two big ones. Yeah, so why is sound different than light? And and why is there no physical experimental evidence? And what else could I add? There's probably some other. What if you just make them go the same speed? Show me how this math is rational in the circumstance where two people are having a conversation on a moving train. Okay. Which was in my initial comment to Professor Lewin. Explain to me how this effect happens in that circumstance, where one person's words are affected more than the other person's words. Okay. No, enough said. I think. Probably could do better and more, but sorry, tired. Kind of a long day and such. Until next time and such.